Hello guys, welcome to another bonus class. Today we're going to talk about executions, execution calculations. So when we really want to do some complicated attack, since like we need to count in the ability, like the attack power and then the armor or things like that, we kind of need to have some way to calculate this stuff right before we really apply the results. Okay, and the gameplay ability system gives you this option here in an effect. So let's actually implement something like that to incorporate a attack power and then an armor attribute, and we can calculate the results based on what kind of how much attack power do we have and how much armor do we have, so we can get different results. So here to start with, we need to create a execution calculation. So here in the C++ class, we're going to go ahead and do that. So new class here, and I can say gameplay effect execution calculation next. And the name is already too long, so I'm gonna say I can delete that gameplay effect. Right. So execution calculation, let's call this a damage execution calculation. Okay, and then create class. Okay, that should create a calculation class for us, and then we can talk about how we use this execution class to actually capture different attributes and then do our calculation and apply the calculated results. Okay. All right, so the compilation is done. We can take a look at what we have here. We have a header file, and of course we'll have a CPP file, right? So here, one thing we wanted to start with is basically having those attributes. So in the attribute set, right, let's create two more attributes. Okay, I can copy from this guy and paste it twice, and then I can call this guy attack damage. Okay, and this guy will be armor, right? So I'm going to use attack damage and armor to determine the eventual the final damage that will be applied to the house. Okay, now those two can be initialized again in the initialization list. We can say attack damage will be equals to I don't know, like 20.0f. Oops. And then the armor will be something like 5. Okay, now we have two more attributes. Okay, all right, now back here to our execution calculation, then we can start to declare some captures we can do. Okay, so here we can say u property pointer, and then we can name it maybe we're doing damage to house, so we probably need to capture the house. So we can call this guy house property. Okay, oops. And then we can also do another one called f gameplay effect attribute capture definition, and then this is going to be the house definition. Okay, so you need to declare those two variables to be able to capture the house property, that you can go ahead and do things like reading it or writing it out, change it, whatever. So you need those two things. All right, so those are the declaration, and we can define them in the constructor. So let me do a constructor here. I just maybe copy that. Okay, and then I can implement or define those two things. So the house property, right? House property will be equals to the property of the our attribute set, and that's actually what we're doing. The same thing we were doing here, like find field checked. We can basically copy this. We can also just do it here right away, right? So we're gonna say find field checked. Okay, and then we're using the class of the attribute set, so we need to include that. So include attribute set base base. Okay. All right. And then in the find field checked, first of all, we need to say this is the U property, right? And then we need to say this is going to be captured from the attribute set base. The base static class. And then we can also say we're going to get member name checked, right? Name checked. Okay. Member name checked. That's actually the macro. So get member name checked. Okay. And then we need to get the class name and then the attribute name. So class name will be attribute set base, and then the attribute will be house, right? House. Just to be safe, I can copy the house over here and go back and paste that in. All right. So that's how we got the how we initialize the or define the house property, and then we need to also define the other guy here, right? Our house definition, right? So house definition will be equals to the constructor of the type, right? And we can then pass in our house property, and then we can say gameplay effect attribute capture source, and we can define where do we want to capture this. So because when you apply a gameplay effect, you have the source, right? Who applied this effect, and you have a target. Who is this effect applied to, right? You have two sources. You want to specify which one you want to capture, but in this case we need to capture the target because that's what we want to change, right? And then one more attribute here, one more argument here called in snapshot. That's basically asking you, do you want to capture it and store that value right away, or you want to have a real-time update? So whenever it changes, it will change here. In this case, doesn't really matter because we don't have any latency, right? It's going to be applied right away, so there will not be any different. But in case you want to do things like a fireball or something that does have the a delay, right? You kind of wanted to capture, like for example, the attack damage. You want to capture it when you generate this gameplay effect, and so that when the fireball reaches the enemy, it's going to use the generated this instance when you generate it, right? This instance, what's the attack power, so that when down the way you just got upgraded or leveled up in the middle, but you still want that original fireball you fired out to have the same amount, to have the old amount of attack damage or things like that. So in this case, I'm gonna say I don't really need to keep updating. So true, just do a snapshot to give me whatever value we're having right now. Okay. All right. So that's how we capture stuff, right? Two variables, right? U property pointer, and then a type of this gameplay effect attribute capture definition. Very long name, but yeah, that's just the way it is. All right, so with those two things, then we can specify one more thing, which is we can actually do a relevant attribute to capture. A relevant attribute to capture, and we can add this new attribute we want to capture. So it's going to be our house define. Okay. All right. Now this relevant attribute to capture, if you take a look at what that is, basically this is basically you want to specify what attribute that you are that is relevant to the calculation you kind of wanted to capture it. Okay. All right. So that's all we have to do to the bare minimum, right? That's the thing we need to declare and define. All right. Now a function we need to implement, which will be one of the base class functions. This guy over here called execute, but they actually want you to execute that to implement that execute implementation function. So we can copy all of these things here to our header file. Okay, but we kind of wanted to change the name to implementation because that's how they want us to do it. Okay. So implementation. Okay, implementation. and then we can put it here, right? So let's check the kind of wanted to know the scope. So it's public, so probably need to make it public here too in our header file. So let's go ahead and do that. Can make everything here public. Okay, you can do your own scoping and design it, but at least this one should be public. All right, so after this we can just go to the implementation and we can do whatever we want. Okay, so let's do the bare minimum. Okay, so I need to get the captured house. Actually, I don't really need to have that. All I need to do is, if I want to change it, right? Let's just do our change and see if it works. So what we need to do is just basically say the out execution output, and we're gonna do a add output filter modifier actually, and then we can just say I've gameplay modifier play modifier evaluate data. Okay, and then we want to pass in here will be first of all the property. Okay, and then how do we want to change it? So is this going to be the gameplay modifier operator? Oh, I'm missing an A. And then we can specify the type we want to do. You can see those are the ones you see actually in the modifier in the gameplay effect, right? You can add, you can division, you can multiply, or you can override it. In this time, I'm going to use additive, right? And let's just type in a fixed number just to see how you can do with the bare minimum. So we can say -100. So that will actually basically say adding -100 to the house of the target, because we're capturing the target, we're changing it here, right? So that's the minimum we can do here to make it work. So let's go ahead and take a look at the result. Let's compile this guy. All right, so the compilation is over. Let's go to let's do that on our melee attack. So back here to the abilities, and let me look for the melee. Okay, now that's our melee damage. For now we're using the curve table to define the damage amount, right? So here in the modifier, I'm going to delete that. And here, go to execution, add a new execution, and then you can see our new execution will be in the list. Okay, and that's the bare minimum we need to do. Just have that there, go compile, and let's go ahead and play our game. If you attack the enemy, oops, I got crashed. Okay, let's just close that, and maybe you just need to recompile it. Sometimes, you know, those kind of things needs a recompilation and reopen the editor to make it work. So let's wait for that to finish. All right, now we're back, and I have changed it back to the damage execution, the thing we just did, right? Just add one here, right? Just add one over here, right? And have that selected, and then you can do your damage, and let's take a look. You can see it's doing like 100, right, damage to the enemy, and it's kill her, right? All right, so that's the basics that we can do with its setup. Okay, so let's take a look at what we can extend from there. Okay, so let me go ahead and open that. Okay, so one thing that is quite annoying here is that you have to do all those things just to capture one attribute, right? And so you have to go to the header and do these, and you have to do these, right? So if we have a lot of more attributes to capture, then it's gonna be a lot of work to do. So luckily they have actually implemented some macro to make all those things automatic, or most of it. So here, if you take a look at the header, the parent class here, you can see now on the very bottom you have two macros they implemented for you to actually make the definition and the declaration easier. So what you just need to do is just go here and say, you can do a comparison here. It's basically doing what we're doing here. You can see we create a U property, right? And create that, and which is also here. And if you're familiar with macro, Unreal Engine uses macro like all of the places, and you can see, you know, they're using it here also. So you can see it's basically saying that you add the attribute, you add the property in the naming of that variable, right? Those two hash means you're gluing those two together as one thing, and you create a definition, right? And then those two lines are identical to these two lines we did here. You can see find field checked here, and there, the definition thing. So that means we can actually do something else rather than just do that ourselves. We can use those macros to help us to declare and define the captures. Okay, so oftentimes you can actually use this particular technique to actually create a global variable to help you to get the things you need, to capture the things you need. So you define a structure here in the CPP file, and you can name this structure like damage statics or something like that. Statics. Okay, and then you can use those two macros to do a declaration for the members and definition in the constructor. So we can basically call that declare attribute capture define, right? And we just need to pass in the attribute we want to do. And this time, let's actually capture the other one we did here. The attribute set, we have the attack damage and armor, right? Let's do those two things. Oops. So this is going to be let me copy the name, attack damage. And here we can basically pass it in. And this one macro does what we need to do here, does those two lines. Okay. And then we can basically copy that and paste that. And I can change that to armor. That way we save some time having to type in all these, right? So that's the declaration. And definition, we do that in the constructor of this structure. So we can say damage statics, and then we basically do the define part over here. So we just need to copy this, right? And then we need those four arguments. S is the class, basically is what attribute set you are referring to. Then that's going to be your attribute set base, right? And then P is the property, so that's going to be our attack damage in this case. Attack damage. And then get member checked, we'll also use the S, right? And the T here will be the target. Do you want to use the target or the source? Okay, so damage, that will be, you guessed it, source, right? Because we're asking for the sources. Sources damage. Okay, and then the B, this boolean is basically the boolean we use here, right? So that's gonna be it doesn't matter, we can do true, just save some performance, I guess, right? And we can do the same thing for the armor. The armor will be here, right? Armor, and we're asking the armor of the target. Okay, all right. So this structure takes care of all the declaration and definition of the attribute we want to capture. So that's why we create a structure to help us. This is a helper. It's not quite necessary, but I start with the bare minimum, so that helps you to understand it gradually instead of seeing me doing all those weird stuff and you don't know what I'm doing here, right? So one more thing, we can actually create a static function to always get one copy of this damage static structure. So damage statics. Okay. So here we just create a static damage statics. Okay. And then we can call this damage damage statics var, and we just return that. Okay, so because it's static, it's gonna only create one, and because we're passing by reference, so it's gonna be that one every time when we just call this. Okay, so here, instead of saying okay, we just add this one, we can basically say here we can say relevant attribute to capture add, but this time we just get the damage statics, and then we can say we're looking for the attack damage, define, and we can also capture the get static and armor define, right? So now we capture the other two. So you either use this way I showed you in the beginning, you just do the member variable way, and you do that here in the constructor to define those two variables, or you create a static, you create a structure, right? And you use the structure to you create a static function to get a copy of that structure, and that does everything you need to capture those attributes. You know, some neat trick that you can use. Anyway, so now we have those two more attribute that we can use. Now let's actually do our calculation, right? That's the important thing here. So we can actually capture stuff. We can do like a floats. I can call this one attack damage, right? Magnitude. So I'm asking what is the attack damage magnitude from the source, and I have that already here, right? Already defined. So what I need to do is basically say the I cannot really make it equal to something yet. Let's initialize with 0 for now, and then I can say, okay, the execution parameter here, that's the knowledge or the information that contains the gameplay effect, or many things. So here, execution parameters, I'm going to ask you attempt to calculate the captured attributes magnitude, right? So this one. Okay. Now I'm capturing the attack. I'm capturing the attack damage. Okay. So I need that definition to pass in. Okay. And then I need something else called the evaluation parameters. Okay. Because it's a constant, we can pass by R value. So we can say we can just create one right here. So say f a aggregator evaluation parameters. Okay, I can just use the default one. I don't really need anything, and then I just need to pass in pass it by reference to use to actually change the value here. Okay, so that's how we get the attack damage magnitude. Okay, after this line of code, the source's attack damage value will be in this variable. Okay, and we can do the same thing for the armor, right? So we can say, okay, float armor magnitude equals to 0.0, right? And we can basically copy this line and say, okay, I want to know another thing, which is gonna be the armor, right? So armor, and then it's gonna be put into this variable, right? All right, so now we have the damage, we have the armor. We can do whatever calculation we want to do. So we can say, okay, floats final damage will be equals to the attack damage magnitude. We can do multiplication, divide, or minus whatever your game mechanic will be. Let's just use a simple. Basically, this is how you calculate stuff, right? So here you can do your calculation, and that's all up to you. I'm gonna do the simple one, just minus the armor, right? And then we got the result, and that's the final damage will be then passed in here. And it's going to be a negative value because the final damage will be a positive value here, and I want to negative that. A little catch here: what if the armor is bigger than the damage, right? So we can say, how about we clamp it, or yeah, we can clamp it. So f mass clamp. Okay, so we're clamping this value here, and the mean will be 0, the maximum will be this guy, right? Right, so it's good to do some clamping. Oh, so int float. Oh, that should be like 0.0. Okay. Anyway, so now we have done our calculations. It's gonna be at least bigger than 0, and we minus that. And in our default settings, it should be doing this. So we capture the attributes, and the default setting will be 25, right? So our damage will be 15, right? So if we do this, when we attack, the enemy will get like 15 lesser health points or hit points. Okay, so let's go ahead and do a compilation and take a look. All right, so the compilation is done. Let's go ahead and do the attack. You can see now we're attacking like every time with 15, right? Okay, all right, so let's extend it a little bit more. So for now, all we did is just 15, but you do remember that we have implemented the combo, right? So our combo actually will have different amount of damage, right? So when we have the second combo and third combo, it should be like having more and more damage. And this is worse, right? This is even worse than what we have earlier, because you will always get 15. And so let's see how we can change that. Now back here to our abilities, and the melee here, we can say, okay, we're using this execution, but before you execute it, there is actually a calculation modifier that you can actually, make adjustment before you do your calculation. Okay, so I can modify some of the things I captured. For example, I want to actually modify the damage. Let me add one here and open that. You can see you can choose one of the things you captured. Here you can see we're capturing the target health, we're capturing the source's attack damage, we're capturing the target's armor, right? I want to change the damage here. Okay, so I'm gonna say, okay, I'm gonna actually change the damage by overriding it. I'm gonna use the damage I was using, which is gonna be the curve table, right? And this will be 1 now because we don't really want to change it to negative because it's already done in the code. And we can choose our melee combo damage. Okay, so this time our before it does all the calculation, if you can go back and find out my code. So before we do our calculation or our capture, basically, when we're capturing it, when we're capturing this attack damage, it's gonna say, okay, is there any modifier? If there is, for example here, and what does it do, right? It does override the value, so it's going to capture this value instead of whatever it is from the actual attribute set. Okay, so this is going to give you one chance to actually change any captured data before it get captured. Okay, all right, so now we'll have our combo back. Let's go ahead and play. Yeah, you can see now my combo is back, right? So I have more damage in the last combo. Okay, all right, so that's basically the thing you kind of want to know more or less to be able to implement yours. Use the execution calculation. You can change how you calculate. Okay, and there's some extra stuff that you can try to do. Like in here, you can get many different informations. Like if I wanted to get for example, the ability system components, you can say U ability system component pointer, and then I can say this is going to be the target one, right? Ability system component, yeah, that's how you say it. And then that's going to be the one we can get from the execution parameters, right? And then get target, and then you know what to do if you want to get the source, right? So there are a lot of informations you can get from this structure, gameplay effect execution parameters. You can say source ASC equals to this guy, and get source ability system component. You can get even the actor, you know what to do, right? You can say source actor will be equals to because the ability system component actually has the owner, which is basically the source or the target. You know how to do that, okay? And then you can also get actually is the gameplay effect spec. So our gameplay effect spec, which contains all the information with that gameplay effect, and can create a reference spect would be equals to execution parameters and get owning spect. Okay, and it's a constant, so we have to make it constant. Okay, so we can get that information, and you can get other things like with this spect you can get the tags you have. So you can say spect get captured attribute, captured source tag or target tag. You can get the tags and use the tag to do something, whatever, because that's your calculation. Now you have to do it yourself and to think about like if there's a tag you want to be able to use to block things or whatever. And those tags can be actually added to your aggregator evaluated parameters. You can say you can create one here. Params maybe, right? And then you can say params dot and then source tag equals to spec capture source tag, just to have the source tag also included in the calculation, and it's gonna actually give you some extra information when it's calculating. It's gonna you know, here this one will use that to calculate whatever you have internally. Anyway, so I think that's basically it, unless there's something I overlooked. It has to be constant again, so I can create a constant one, but you know what to do with that, right? So anyway, but oftentimes I don't really need to use a lot of information here. If I don't need those, I don't really capture, but that's basically the essential knowledge for execution calculations. This could come in handy when you really need to wanted to calculate exactly how you want it to calculate, right? And this is where you do it. All right, that's gonna be this bonus video. I hope that helps you to be able to extend more on the features of gameplay ability. And if there's some more requests, I can keep adding new ones just to broaden our knowledge. But many of the things is actually something you can research yourself. I don't intend to explain the totality of this gameplay ability system. It's actually pretty deep. It does have so many different things and structures internally, and you kind of. But for any programmers, you know that programming is basically learning what you have to do, right? It's not like you know everything already. You don't know them. Oftentimes you just have to read some source code, see some comments, and see what's doing, right? Learn the function you're using. That's basically part of the job. So I do encourage you to try something before you ask, because that way you actually practice your ability to do coding. Anyway, that's gonna be it for this video. Thanks for watching.